Okay, today we will learn about the blood groups and the blood transfusion. So, assemblers are for today's lecture. List the blood group system, describe the ADO system, RH system, steps, Land's law. Land's law is important. Short note on the Land's law, or for the brief question, it may ask, state the Land's law. Then describe the mode of inheritance of the blood groups. Discuss the importance of the blood groups. Discuss the importance and methods of cross-matching, direct and indirect. List the physiological basis of symptoms and treatment of RH incompatibility. List the hazards of blood transfusion. Again, hazards of blood transfusion important. Describe the complications of mismatched blood transfusion. So these are the SMOs for today's lecture. Then, what is the blood group? What is the importance of the blood group? So in the blood group, all the human red cells on their surface, there are the surface antigens are present on the RBC. So on the surface of the RBC cell membrane, there are the antigens are present, and these antigens are the blood group antigens. These are the blood group antigens. When the antigens are present on the surface of the RBC, the respective antibodies are absent in the plasma of that individual, and with this the antigen and antibody, we can determine the blood group of the individuals. So these antigens are the agglutinogens which are present on the cell membrane of the RBC. Antibodies, these are the agglutinins which are present in the plasma of the individual. Reaction between antigen and antibody causes agglutination or the clumping of the red blood cells, which we observe or our observation in the blood group or the detection of the blood group. There is agglutination between the antigen and antibody, and from that agglutination or the clumping, we can determine the blood group of that individual. And more than 30 blood groups are in our system, having 400 antigens. In that 30 blood groups, there are the 400 antigens. Many of them have the cold antibodies. Cold antibodies are the antibodies which are not react at our body temperature, 5 to 20 degrees. And warm antibodies are the antibodies which react on our body temperature. So there are the two types of the antibodies, cold antibodies and the warm antibodies. IgM antibodies are called as the cold antibodies. IgG antibodies are called as the warm antibodies. And another system in the blood group is the RH. ABO and RH system, that is RH positive and RH negative, which is derived from the rhesus group. And major other systems are MNS, Lewis, Duffy, K, P, and Lutheran systems. You can enumerate, you can able to enumerate the other systems. Only the names of these systems are important for the Viva. Then these are the types of the blood groups and the genes which are present in that blood group and the number of antigens present in that blood group. So 30 blood groups are there and 400 antigens are there. Various types of the blood group like ABO, RH, MNS, P, Lutheran, K, Duffy, P, Lewis, Dago, Catrite, XG, Li, like this. There are 30 blood groups and total antigens are the 400 antigens are present. Then what is the importance to check the blood group or to know the blood group? It is our identity. So our blood group will be mentioned on our ID card. In emergency, if there is a suppose there is an accident and there is a huge severe blood loss, or there is hemorrhage occurs and he requires the blood transfusion. If you know his blood group, you can immediately give blood transfusion to that fellow or to that individual. So it is our identity. So blood group should be known, and this is the comparative test between the antigen and the antibodies. Then this provides a scientific basis for the understanding the hemolytic diseases like the thalassemia or the other erythroblastosis fetalis, which is present in the RH negative mother if it is a transfused or the second time in pregnancy. RH antibodies are developed during the first pregnancy. So in the RH negative mother, there are the more chances of the erythroblastosis fetalis. So they give the scientific basis of the understand some information about the hemolytic diseases in the newborn and the autoimmune hemolytic anemias. Then they also play a critical role in the susceptibility of the infections like the malaria, bacteria, viruses. These are associated with clinical disorders, and for the medical legal cases or the disputed paternities, from this blood group we can identify the father or the mother, maternal disputes or the paternal disputes. And MNS blood group system is very important, or it play important role in this field. This disputed paternities, MNS. Other than ABO, MNS is very important for this disputed paternities, identification of the this. Then first we will see about the ABO blood system. This is discovered first in the 1901. Is the most important system in the transfusion medicine. Physiologically, in our blood group system, there are the no natural antibody. Normally, what happens when there is an infection or there is an attack of the antigens in our body, then there is a development of the antibodies. When antibodies are developed, when there is a antigens are introduced by externally or there is attack of the antigen, then there is a development of the antibodies. But these antibodies, they are the naturally present in our body. They are naturally present in our body since the birth. So these are the ABO. These antibodies are present in the plasma, and antigens which are present on the cell membrane of the red blood cells. There are two types of the antigens present, A and B antigens. Subtype of the A is A and A1. Occurs on the membranes of the red cells, also found in the tissues like the salivary glands, testes, lungs, kidney and pancreas. Some individuals, especially O group antigens, secrete H antigen in the saliva and body fluids. Only this O blood group individuals secrete this H antigens in the saliva and other body fluids. Time of appearance, they appear at the 6th week of the intrauterine life. These antigens A and B appear at the 6th week of the intrauterine life. Concentration reached at the adult level at the 1/5 of the, at the birth they are only at the 1/5 of the adult. Start appearing at the 6th week, reach at the adult level 15 to 70 years of the age. So, for the blood transfusion, we choose the age of the donor is more than 18 years because the antibodies are fully not concentrated. Their concentration becomes at the adult level at the age of the 15 to 70. So, what is the appropriate age of the donor is 18 years. Donor should be at least 18 years age, not less than the 18 years. At birth, very low concentration, at least just maximum 15 to 70. This is very important. Then blood group are based on these the antigens. In blood group A, antigen A is present on the cell membrane of the RBC. Corresponding antibodies are A antibodies are absent in that group. B antibodies or the beta agglutinin are present in the blood group A. Understand? In blood group A, antigen A is present, antibody A absent, and antibody B is present in that group. In B blood group, antigen B is present, antibody A is present. Then in blood group A, both A and B antigens are present, both antibodies are absent. In blood group O, there are the both antigens are absent and antibodies A, B and H. In the A, B and H antibodies are present. Subtypes of the A and A1 are the A1 containing A and A1 antigens, A2 containing only A antigen. There are two subtypes A and A1. In A1 there are the A and A1 antigen, and in A only A antigen. A2 containing only A. Again, for the AB, A1B and A2B blood groups are there. Distribution among the Indians, more is O blood group, that is a 34%, less AB 8%, B 31 and A blood group is a 27. This is a percentage of the blood group. A again for the A1 is of 75 and A2 only 25%. Then role of the H gene and the H antigen. So A and B antigens depend on the presence of the H genes. Most of the individuals are homozygous for the H individuals. A and B red cell antigens are these are the glycoproteins. Their formation starts with the precursor substances. Their formation starts from the precursor substances. Suppose in next slide see. If we see basic precursor substances there, basic precursor substance, and in the presence of H gene, this basic precursor substance is converted into H substance. In the presence of H gene, this basic precursor substance which is present in our body is converted into H substance. This H substance, with the presence of A gene and B gene, with the presence of A gene and B gene, with the transferase, is converted into the A antigen and the B antigen. Remember? Basically, there is a basic precursor substance is present. In the presence of H gene, this basic precursor substance is converted into H substance. This H substance, with the presence of the A gene and the B gene, is converted into A antigen, B antigen. But for the O blood group, there is a no A gene or the no B gene, so it is a not get converted. So there is a no formation of the antigen A or the antigen B. And so there is a with B antigen, B blood group, with A antigen, there is a antigen. Then what happens with this H antigen? O blood group individuals have no A and B genes. A and B antigens are not formed, but some individuals have H. Some individuals have the H antigen, and they may be detected in the saliva or body fluids. These individuals are called as secretors. These individuals are called as secretors, while remaining individuals are called as non-secretors. A and B antigen is absent in the O, but H antigen may be present there. So they are called as secretors, and if they are not present, it is called as non-secretors. From that basis, there is a new blood group is there present, which is called as a Bombay blood group. Is a Bombay, again this is a Viva question, Bombay blood group, which is discovered in 1952 by Bende, Bhatia and the Deshpande. In these individuals, there is a H gene is absent. There is a H gene is absent, and there is a formation of the, there is no formation of the A and B antigen, but there is a and B genes are the absent. When this sample is checked for the AB grouping, they labeled as O because A antigen and B antigen is absent, so they label them as O. But their serum contains A antibodies, B antibodies, and H antibodies. Their serum contains A, B, and H antibodies. So they are known as a Bombay blood group. So these people are only transfused with the Bombay blood group because antibody H is present is there. Then agglutinins, that is the antibodies. There are the two types of the agglutinins, of the two types of the antibodies are present. Alpha antibodies and the beta antibodies. They are present in the plasma of the individual. There are the two subtypes, alpha and the alpha 1. These are the naturally occurring antibodies in our body. Chemical nature, these are the globulins. They are IgM category. They not cross the placenta and they work at the 5 to 20 degree centigrade temperature. So these are called as the cold antibodies. These are the IgM type of the antibodies found in the plasma and they are reactive at 5 to 20 degrees temperature. So they are called as the cold antibodies, not cross the placenta. Then antibodies against the blood groups. So now you know in the blood group A, there are the A antigens are present, A antibodies are absent. Same. B antigen or the beta antibodies are present in the A group. Same for the B. In B group, B antigen present, B antibodies are absent. For the O blood group, there are the A and anti-A and anti-B, both antibodies are present in the O blood group. In their plasma, both types of antibodies. And in Bombay blood group, A, B and H, three are the present. And this is noted and described by the Carl Landsteiner in magnetic membrane, and theory is known as a Landsteiner's law. Theory is known as a Landsteiner's law. So he got the Nobel Prize in 1930 for this law or this story. So what is the Landsteiner law? Landsteiner law states that if a particular agglutinogen is present on the same red cell membrane of that individual, the corresponding antibodies are absent in the plasma of that individual. Or if the antigens are absent on the red cell membrane of that individual, corresponding antibodies will be present in the plasma of that individual. So this is the Landsteiner's law, which is important for the detection of the blood group. From this law, we can detect the blood group of the individuals. Again, same antigen A, red cell membrane, antibody B in plasma. For B antigen and A antibodies. For O, both absent, both antigens are present and antibodies are absent. For O, antigens are absent and the antibodies are present in the plasma. Then, how to determine the blood group? For the determination of the formation of the blood group, the red blood cells of the individual are suspended with the antisera. They are suspended with the antisera, which are commercially available. And if there is a clump formation or there is agglutination is seen, that blood group is present. Suppose you done this practical blood group BTCP. One batch only finished, A batch. So in that, we draw the blood by the finger prick, one drop of the blood, and in this there are the 3 to 4 depressions are there for one group A, B, for one is for the O, and one is for the Rh positive or the negative. So we put one drop of the blood in this pits A, B, O, and AB, and we add the antisera. In A blood group, we add antisera A. In B, antisera B. And in Rh positive negative, we add Rh positive or the negative. And in the AB, we add nothing. So what happens if there is agglutination or clump formation is seen in the A group? There is A group is present. If there is a agglutination in the B, there is a B group is present. So see, first there is agglutination A in the A depression. So there is a blood group is present. In second, there is in B there is agglutination. In third, there is no agglutination in the A and also in the B. So antigen A and antigen B is absent in the O. So this is a O blood group. And for the AB, there is agglutination in the both. Also in the A and also in the B. So the group of that individual is an AB blood group. From this, you detect the blood group of the person of the individual. Then inheritance of the blood group. Inheritance of the blood group, these blood group antigens are in the dominant characteristic. These are the in three genes are there present in the blood group O, A, and B. If we see this genotype of this A, B, and O, what is it? O, A, or the A. Suppose there are the 3 A, B, and O. What happens? It may be AB, it may be A, it may be BO, or it may be A. There are the 6 types of the phenotypes to be found. That is O, AA, OB, or BB, and the A. O gene is genetically important, and phenotype may be A, B, AB, or the O. For example, if the patient's blood group is A and one parent's blood group is A and other parents is B, the child may have any A, B, or the A. So again, see, this is the phenotype A and B, genotype AO or BO, gametes, and then what is the formation genotype AB, AO, OA or the O. Up part is not. It's blood group A or AO, B, BP or BO, like AB, and O or O. This is the ABO RH system. The next system is the RH system. That is RH positive or the RH negative. RH system, that is the rhesus system, is the second most important blood group system, first described in rhesus monkey in 1940 by Lance Taylor and Miller, called RH system for the rhesus. What they do? First, they draw the blood RBCs from the rhesus monkey and they inject these RBCs into rabbit. First, they draw the blood from the rhesus monkey and this blood they injected into the rabbit. What forms in the rabbit? Antibodies against this rhesus monkey RBCs developed into the rabbit. They develop the antibodies into the rabbit, and these antibodies, bring in contact or they inject into the human being or in the blood of the human. What happens? There is a agglutination or there is a clump will be formed. These antibodies forms the clumping with the human being's blood or the red blood cells of the human being. And so there is a discovery of the RH system in the humans. Again, there are the 6 antigens are present, capital C, D, E and small c, D, E. But most important is the D. D is the most important, which determines RH positive or the RH negative. D antigen determines RH positive or the RH negative. If D gene is present, it is called as RH positive. D gene is absent, it is called as a RH negative. They are located on the chromosome number 1. They are also the membrane proteins and found on the red cell membrane. RH antigens are also the membrane proteins. Inheritance, 95 to 98 people are RH positive, only 2 to 5% people are the RH negative. If one parent is homozygous, so what is homozygous? D, see this is. If there is a RH D, capital D, homozygous. Or the both small d, these are called as a homozygous. So, if one of the parent is a homozygous, then there is a formation of the offsprings. One of the parent is homozygous positive, other is homozygous negative, and offsprings will be heterozygous positive. If other and mother is homozygous negative, offsprings will be homozygous negative. One parent heterozygous positive, other homozygous negative, 50% homozygous positive, 50% homozygous negative. That is the inheritance of the RH antigen. Then RH antibodies. RH antibodies produced only in the RH negative. This is again important. RH incompatibility or the erythroblastosis fetalis. Short note: erythroblastosis fetalis. So, what is the importance of the RH antibody? These RH antibodies which are produced in the RH negative individual when receive RH positive. When RH negative person is mistakenly transfused with the RH positive blood, what happens? There is a clumping or the agglutination will be formed and there is the antibodies will be developed. These antibodies are the IgG type. These are the IgG type. They cross the placenta. So there is a development of the erythroblastosis fetalis in the RH negative mother. Why? These antibodies are IgG type. ABO blood group system antibodies are IgM type. And these are cold antibodies. These are IgG type, can cross the placenta, and they are the warm antibodies. These are the warm antibodies because best reactive at the body temperature. They are best reactive at the body temperature. So these are called as the warm antibodies. Type of antibodies are the IgG cross the placenta. When the antibodies will be formed in the RH negative person? First time you can give or you can transfuse with the RH positive blood, nothing will be happening. nothing will be happen. Because that time, that takes the time for the formation of the antibody. It is not the immediate reaction. ABO cross match or the ABO mismatch is an immediate reaction. ABO. Suppose in the A blood group patient who transfuse B blood group blood, that time there is immediate reaction will be up. But in the RH incompatibility, it is a late reaction. So first time, if you transfuse negative RH negative person with the RH positive person, there is no any damage. The person will be not get hampered. Second time, if you do same mistake, that time there will be risk. Because first time, because of the cells, these memory cells which are formed, they develop the antibodies, and second time they develop the response. So only one time you can give the RH positive blood to the RH negative person. Only one time you can give. And this is the principle in erythroblastosis fetalis. It takes 2 to 4 months for the development of the antibodies. RH incompatibility, it takes 2 to 4 months for the development. Then we see about the erythroblastosis fetalis. What happens in the erythroblastosis fetalis? Mother is RH negative, father is RH positive, and baby is RH positive. If the baby is RH, fetus is the RH positive. What happens during the parturition or during the separation of the placenta? Leakage of the blood from the mother's womb is a transfer to the mother's circulation. From the uterus, it is transferred to the circulation, and there is a development of the antibodies in the mother's circulation. Because these antibodies are the IgG type antibodies, they cross the placenta, so they cross placenta, and there is a formation or development of the Rh negative antibodies in mother's circulation. So first maybe there is no any risk. Second time, if that female get again pregnant for the second time, who have already Rh negative antibodies in the circulation. These antibodies cross the placenta, they go into the fetal circulation, and there is a agglutination, or there is a clumping of the antigen and antibody, and again there is a hemolysis. There is a hemolysis will be occurred. So during first pregnancy there is no risk, but for the second pregnancy there is a development of the antibodies after the first pregnancy, so there is a risk for the second baby or the second fetus, because they cross the placenta, they go to the fetal circulation, and there is a incompatibility occurs in pregnancy which bears the Rh positive, which leads to the erythroblastosis fetalis. It leads to the erythroblastosis fetalis. So what is the erythroblastosis fetalis? It is a hemolytic disease in the newborn. Why these lines are there? This is red and green. Huh? Who? Who scratches this? Who? Students. Why they are doing like this? So erythroblastosis fetalis is a short word. So it is a hemolytic disease in the newborn due to Rh incompatibility. When Rh negative mother carries Rh positive fetus, usually no reaction during the first pregnancy. At the time of the placental separation, small amount of the fetal blood leaks into the maternal circulation and induces formation of the anti-Rh agglutinase. That is, there is a Rh antibody formation in the mother. During second pregnancy, that is subsequent pregnancy, there is a Rh agglutinated from the mother, which are IgG type, cross the placenta, go to the fetus, and in fetal circulation it causes the hemolysis. And in subsequent pregnancies, hemolysis becomes more severe in the second, third, or the fourth pregnancy. What are the clinical signs? Because in this erythroblastoma fetalis, because of the hemolysis, there is a anemia, and there may be extramedullary hematopoiesis. Hematopoiesis will be occurs outside the bone marrow. That is the capillary hematopoiesis. Because of the hemolysis, bilirubin level will be raised, which causes hyperbilirubinemia. And anemia is proportional to the degree of the hemolysis. More anemia, less hemolysis, less anemia. And it causes hemolytic jaundice because there is a raised level of the bilirubin more than 25% milligram percent, more than 25%. And because of this anemia, there is a development of edema, which is called as a hydrops fetalis. Hypoproteinemia and anemia causes hydrops fetalis. So, what are the signs of the hydrops fetalis? One is the anemia. Second was the hemolytic jaundice because of the raised bilirubin levels, and third one is the hydrops fetalis because of the anemia and the hypoproteinemia. In Kernicterus, this is a neurological syndrome which is occurs because of the deposition of the bilirubin in the basal ganglia of the fetal brain. There is a deposition of the bilirubin in the fetal basal ganglia. The blood-brain barrier is not fully developed in the fetus. Blood-brain barrier is not fully developed in the fetus. So, bilirubin cross the blood-brain barrier and they are deposited into the brain. In adult, because of the full development of the blood-brain barrier, there is a no transmission of the bilirubin to the adult brain. But in the fetal, they cross the blood-brain barrier and they are deposited into the basal ganglia, and it is called as the Kernicterus, where there is the motor dysfunctions or occurs. So the control of the body, motor control of the body will be lost because there are the in basal ganglia, there are the nucleus which control our body, and this bilirubin which is deposited in the basal ganglia, motor control is affected and there is causes motor dysfunctions. Extramedullary hematopoiesis because of the severe anemia which in the erythroblast. It may be asked what are the clinical signs of the erythroblast or enumerate the clinical signs of the erythroblast, is 2 marks. So anemia, hemolytic jaundice, hydrops fetalis, Kernicterus for the 2 marks. Brief question. Only enumerate, that time only you 1, 2, 3, 4. Enumerate this for 4 marks or 2 marks. So what is the treatment for the erythroblast fetalis? 50% fetuses are newborn with this erythroblast fetalis require no treatment, only phototherapy is given. They keep these newborn babies under this phototherapy, So phototherapy for the 50% cases. Sometimes they give the inter-uterine transfusions and exchange transfusions. For the severe anemia, they give the exchange transfusion. That is the double volume exchange transfusion is given RH negative and cross-matched against the mother's blood. Phototherapy is most effective and they are commonly used to reduce the serum bilirubin level. Only enumerate treatment exchange transfusion, that is intrauterine transfusion or the exchange transfusion, but important is the phototherapy. Other systems are MNS system was described in 1927, MN and S. There are 3 antigen, M, N and S. They are expressed on the endothelial cells of the renal capillaries. They are a major contributor for the negative charges on the red cell membrane. Phenotypes are M, N, MM and S. Helpful for solving the paternity disputes. MNS. By what? Which system is more important or helpful for the solving the paternity disputes? MNS. MNS group useful for the anthropological and the genetic studies also. The anthropological studies and also for the genetic studies, MNS system is helpful. Other system is the H system. Antigen, H antigen is present. Depends on the expression of the ABO, especially O group. You see that, where that is H antigen and how there is a Bombay blood group. So this H antigen is the FUT1 located on the chromosome number 19, present in plasma. Most body secretions like saliva, sweat, semen, tissues, and endothelial cells, they are secretors or the non-secretors. If they are secrets, they are secretor or the non-secretors. Next system is the Lewis, described in 1946. Two antigens LEA and LEB. In Lewis system, there are the two types of the antigens are present. LE small a, LE small b. Not truly red cell antigens produced in plasma, absorbed into red cells. They are present in body secretions and limb. In chromosome, they are present on the chromosome number 19, and they serve as a receptor for the Helicobacter pylori. These antigens are receptors for the Helicobacter pylori. They are IgM type, not cross the placenta barrier. So not causing hemolytic diseases in the newborn. System. Then IL system, two types of the antigens are I, capital I and the small I. They are present in the plasma, red cells and heme. Red cells of the fetus and neonate are reaching the I antigens, small I antigens. They are changing the I to I antigen in the first 2 years of their life. In hemoglobinopathies, they increase the I antigens. What is the importance of this? I system, hemoglobinopathies. Then blood transfusion. What is the importance of the blood transfusion, or what is the physiological basis of the blood transfusion? Blood transfusion may be done with the whole blood is transfused, that is the whole blood transfusion, or only plasma is transfused, or only packed cell volume, PCV, are transfused. These are the types of the transfusion. That is the whole blood or the components of the blood. Common is the whole blood transfusion is the more common in the treatment of the severe hemorrhage after the deliveries or after the pregnancy or after the major surgeries or into the severe anemia. In cases of the severe anemia, blood transfusion is indicated. It should be careful because there is a chances of transmission of the infective diseases like the HIV, hepatitis. And also there are the hazards of the blood transfusion. Indications for the blood transfusion: acute blood loss like the hemorrhage or the accidents. Whole blood is preferred. Chronic anemia, packed cells are given, PCVs are transfused. Bone marrow deficiencies or the bone marrow, there is a that time in the leukemia or plastic anemia, bone marrow infiltration by the pneumoplastic cells. Bone marrow failure, fresh blood and specific blood components are required. Porphyria, platelet transfusion is preferred. So the porphyria, platelet transfusion is given. Clotting factor deficiencies, fresh frozen plasma is preferred. Preparation for the surgery or during surgery. If the patient is anemic or in the accident severe hemorrhage is there, hemoglobin will be reduced. So prior to the surgery, we give the blood transfusion to the patient and then we done the surgery. We take for the operation. Loss of iron blood tolerated during the surgery in a normal hemoglobin patient. If blood loss is more, that time transfusion is planned. Up to 50 ml blood loss is expected during surgery. It's happening. If we expect more blood loss, more than the 500 ml blood loss, that time we plan the blood transfusion during the surgery or the before the surgery. In burns, there is a proteins lost from the burn injuries. A lot of proteins are lost. That time we give the packed cells transfusion or the plasma-rich proteins are given in the burns. Then in anemias, hemoglobinopathies like the thalassemia, sickle cell anemia, we give the blood transfusion. What is the advantage of the blood transfusion? In sickle cell anemia, what happens? There is a defective cells are not produced. They are given the blood ready-made blood will give to the patient, and there is a decrease the chances of defective red blood cells formation by the erythropoiesis. That is, sickle cells red cells are not formed. This is the advantage. Then, what is the procedure for the blood transfusion? Identification of the healthy and the appropriate donor. Age more than 18 years, you should be healthy. No infective diseases there. No, there is no transmission of the infectious diseases like the AIDS, hepatitis, malaria, filariasis. So, healthy and the appropriate donor. Blood grouping for the RH positive, negative, and the ABO blood grouping should be done of both donor and the recipient. Both RH positive and is ABO blood group for the both recipients and the donor is done. It is called as a cross matching. Then, in mismatched blood transfusion, there may be chances of the agglutination or the clumping. It occurs in the recipient's blood, it causes acute hemolysis and which may be life-threatening to the recipient. Therefore, suitable transfusion should be always include selection of appropriate donor, APO and RH typing, cross-matching, antibody screening of the patient to detect presence of any significant antibodies in the donor. Selection of the appropriate donor, healthy donor, free from transfusion transmissible diseases, ideal age 18 years or above, hemoglobin status for the females 12 grams, for the males 13 grams. There should be no AIDS, hepatitis, lymphomas, or the malaria and the filaria. APO and RH typing is done. APO in comparative causes immediate reaction, RH in comparative delayed reaction. What is the universal donor and the universal recipient? O blood group, O negative, not positive, O negative blood group persons or individuals are called as a universal donor. Why? In their cell on the red cell membrane of their no antigens, A antigen or B antigens are not present on their RBC membrane, so they are called as a universal donor. There is a no agglutination reaction. So blood group O negative can give blood to any individual. So they are called as a universal donor. AB positive are called as a universal recipient because antibodies are absent in the A and AB blood group, whereas A antibody and B antibodies are absent in the individual. So the individuals can take any type of the blood group. After transfusion, any type of the blood group safely. So these are called as a universal recipient. Cross-matching is done before the blood transfusion, major cross-match and the minor cross-match. In the major cross-match, donors' red blood cells are crossed with the recipient's plasma. Donors' RBCs are agglutinated or crossed with the recipient's plasma. It is called as a major cross-match. Minor cross-matching, donors' plasma is matched with the recipient's RBCs. It is called as a minor cross-match. Antibody screening tests are done before the transfusion. Collection of the blood, normally through the venipuncture, anticubital vein, through the anticubital vein, we take the blood collected into the jar or the bottle or the bag. Ideally, 350 ml of the blood at a time is collected from the anticubital vein. It mixes with the 50 to 70 ml anticoagulant. This 350 ml blood is mixes with the anticoagulant, which consisting of citrate, phosphate, and dextrose. Anticoagulant, citrate, phosphate, and dextrose. CPD, disodium hydrogen citrate, is used as an anticoagulant. After blood collection, this donor should be monitored for the bradycardia, hypertension, dizziness. Is otherwise rest and no severe exercises. And don't allow him to donate the blood next 3 months. Or the next 3 months, not allowed to donate the blood. Autologous donor blood, that is the before surgery. This is because of the transmissible diseases like the AIDS and hepatitis. Autologous donor blood. What is this? Cell blood is collected and transfused during the time of the surgery. Same blood is collected before the surgery or prior to the surgery. Collected every 72 hours, up to 72 hours before surgery. Up to the hemoglobin 11 gram. If the hemoglobin falls below 11 gram, we don't collect. Maximum hemoglobin level should be 11 gram after every 72 hours and 72 hours prior to surgery to stop the collection of the blood. Normally 2 to 4 ml units of each 250 ml units are blood is collected and same blood is transfused to that same individual during the surgery. It is called as an autologous. Storage of the blood in blood bank at the 4 degrees centigrade. It should be used within the 2 weeks. Minimum 2 weeks it should be used. Changes occurs during the storage. We storage the blood at the 4 degrees centigrade, which causes there is a reduction in the metabolism in the cell, which increase sodium and decrease the potassium concentration of the cell. Increase sodium, decrease potassium from the cell. Because there is a decrease the activity of the sodium, potassium at the low degree temperature, that is at the minus 4 degree temperature. This causes spontaneous hemolysis. Changes in stored blood. There is a after transfusion, that is in the body of the individual. Cell metabolism will be increases with excluded sodium and there is increase the potassium in the cell. Red cell come back to normal within the 24 to 48 hours. Ideally, blood transfusion should be given within the 14 days of the storage. Ideally, within the 14 days, that is only 2 weeks. Not more than the 30 days is allowed. Hazards of the blood transfusion due to mismatched blood transfusion, that is incompatible blood transfusion. There is a mismatched reactions will be occurred. There is a agglutination and the hemolysis, which causes acute hemolytic transfusion reactions, which occur due to ABO incompatibility. Complications: shivering and fever, that is febrile reactions, hemoglobinopathies, hemolytic jaundice because of the hemolysis. Acute renal failure because hemoglobin pass blocks the renal tubules and damage the tubules. Circulatory shock may be there. Hyperkalemia, increase the potassium ions. So there is a hyperkalemia which causes cardiac arrest. Faulty technique of the giving blood, thrombophlebitis at the site of the venipuncture. There may be thrombophlebitis, air embolism, air entry through the venous circulation. There may be circulatory overload. If you give more the blood transfusion during the 24 hours, there is a load on the heart. So there is a circulatory overload may occur, which causes arrest of the cardiac arrhythmias. Febrile reaction, that is a patient may get rigor or the freeze cold, allergic reactions and transmission of the diseases like the hepatitis, malaria, syphilis. So hazards of the blood transfusion is also important. Hazards of the blood transfusion. So for the today's lecture, erythroblastosis fetalis is short note. Hazards of the blood transfusion is short note. And indications for the blood transfusion is also important. Here we finish the blood. So for the first internal assessment, blood complete, general physiology complete, normal muscle complete. First internal assessment, normal muscle, general physiology, serious कितना होगा, and from tomorrow RS is also open. So topics of RS and CS also there. Come to mark.